Welcome to the third part of our radiographic inspection. Today, we will discuss regarding the IQI of radiography technique and different type of radiographic technique that are using in our industry. So first of all, the quality of radiograph that is determined by some specific kind of instrument that is known as IQI. That means image quality indicator. That means it will indicate that the specific amount of change in the material or in thickness will be detectable into the radiograph. That means the level of sensitivity will be determined by the IQI. The IQI will dictate that whatever the quality of a radiograph that will be directly related with the how much finer defect it can have the ability to identify. In radiography, we are using two type of IQI. One is known as wire type IQI and second is known as plug a hole type IQI. This wire type IQI or the hole type IQI we can using as per the different standard also. As per the ASME standard or in some scenarios wire type penetrometer or wire type IQI also we are using as per the EN standard or the DIN standard. The wire type penetrometer, what is the meaning of it? The wire type penetrometer means it's a series of wire and the wire is in a specific dimension and the material compositions of the wire that will be correlated with the attenuation value of your inspection part. That means the material which is containing into the penetrometer, the same material will be we are using for the radiography. That means the radiographic equivalency factor or by the attenuation point of view, the inspection material and the wire that is available into the penetrometer that will be into the same. That means radiographically both have the same attenuation values. So according to the ASTM classification, there are total 21 number of wire has been selected from the wire number 1 to wire number 21. There are 21 wire is there and this wire has a dimension, specific dimension that is given into the standard of ASME section 5 article 2 or in extended article of AC 747 how the penetrometer wire type penetrometer will be manufactured, what will be the diameter of the wire, what will be their tolerance, everything that is given into the guidelines of AC 747. So according to the ASTM wire type penetrometer, the first wire has the minimum dimension and the last wire has the maximum dimension. That means the dimensions of the wire will be in a increasing manner. So the wire number 1 is the thinnest and the wire number 21 is the thickest. Entire 21 wire has been divided into the 4 groups A, B and C, D and each and every group we are putting the 6 wire. Now what is the penetrometer? What is the configurations of penetrometer? Now selected 6 wire are in laminated in a plastic cardboards. All have equal length and the spacing of the individual wire are predetermined as per the code of standard as per the AC 747. Here the classification that is group A, B, C, D along with that some nomenclature is given into the wire type penetrometer. You can say You can see it here at the top of every penetrometer. There is ASTM, that is the standard. 1A, A is the group, and 1 is a number which will indicate the material composition group. That means according to the AC747, whatever the material is there inside the penetrometer as a wire, that material compositions has been divided into some group number. Here the 1 indicates that it's the group number 1 of the material, and the group number 1 indicates that it's a material made of such material which has the radiographic attenuation values or radiographic coefficient value is equivalent to all grade of carbon steel, low alloy steel, and 300 series of SS. So 300 series of SS, duplex stainless steel, and as well as carbon steel, all grade of carbon steel and a low alloy steel, this penetrometer we can use as a one grouping penetrometer. In the similar, that means the internal wire composition is simply the iron. In the similar way, if you are going for the two grouping penetrometer, that is for aluminium, three grouping penetrometer, that is for the inconel, four grouping penetrometer, that is for the monel, and so on. For the detail, you can write down the whatever the code, that is SC747, and elaborately you can get the group number. But as per the job is concerned into the constructions or into the day-to-day industry, one, two, three, four. These the four group we are specifically using. So 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D. So each and individual group has the four member, and each penetrometer has the six wire starting from the thin to thick. In a similar way, there are another standard that is known as the Dean standard, which is now collaborated with the EN. So it is also known as Dean EN standard. And according to the Dean EN standard, there are total 19 wire is there. Yeah, here we are showing up to the 16, but total 19 wire is there into the Dean standard. And here the diameter of the first wire is the thickest, and the diameter of the last wire is the thinnest. Here the first wire diameter is 3.2, and if we are multiplying it with the zero point 0.8, then the second, third diameter you will get. That means it is in a decreasing manner. And the total 19 wire, here we are divided into the four sets. And the nomenclature of the sets are DIN 1 ISO 7, DIN 6 ISO 12, DIN 10 ISO 16, and DIN 13 ISO 19. And in each group, there are 7 wires putting into that, and 1 to 7, that is into the first group, 6 to 12, that is into the second group, 2 wire has been repeated. In the third group, it is from the 10 to 16, and in the last group, it will be from the 13 to 19. So this is the wire type penetrometer as per the DIN standard. When we will be select the DIN standard penetrometer, definitely the penetrometer selections, that means the nomenclatures of the penetrometer, wire diameter, spacing between the wire, length of the wire, all that detailed guidelines is given as per the ASTM standard E747. In a similar way, in industrial practice, another type of penetrometer we are using, that is known as the hole type penetrometer. Here we are using a rectangle plug, and in that rectangle plug, three hole has been drilled, and the diameters of these three holes are in different. At the center, there is a minimum dimensions of the hole, that is known as 1T diameter hole, and extremely at the outer sides there are a second hole that is known as 2T diameter hole, and at the end towards the numbering sides, here is a bigger diameter hole that is known as 4T hole. So each and every penetrometer has a three drilled hole, 1T, 2T, and 4T. Here the T is nothing, T is the thickness of the penetrometer expressed into the thou. And where we will get the thou values? The nomenclatures or number of the penetrometer. Here you can see that the penetrometer is a number of 25. So 25 is the nomenclature number of this penetrometer. So if the number is 25, then the plate thickness that will be 25 by 1000 inch. That means 1 thou. It's a 25 thou, and 25 thou is equivalent to 0.025 inch. If the values of the T, that is thickness of the plate in which the drill has been done, if it is the 0.025, and according to that, this three drill has been made 0.025, 2 into 0.025, 4 into 0.025. So starting from the minimum 8 thou to maximum up to the 70 to 80 thou is available into the industry. Whatever your job thickness is there, you can purchase it from the purchaser. So minimum 8 thou to maximum 70 to 80 thou penetrometer is available in even and odd number. Now the question is, this all the penetrometer is available, but when we will take the radiograph of your inspection part, the selections of the penetrometer is most important, because if you can select for the wire type or you can use for the hole type according to your project specification, or it has been mentioned into the radiography procedure. Suppose we are going to use the wire type penetrometer or the hole type penetrometer, the selection is most important, and the selection is done from the 2% of the effective thickness. Here the effective thickness means as per your inspection is concerned, your inspection part parent material thickness, that is the nominal thickness, and along with that we will add up the allowable reinforcement and protrusion in case of belt inspection. So according to the ASME B31.3 acceptance criteria of radiography, we can take the table as a reference. So whatever the maximum reinforcement and protrusion that will be allowed. So according to that, up to 6 mm, we can consider 1.5 into 2, 1.5 mm as a reinforcement and 1.5 mm as a protrusion. From 6 to 12.7, it will be 3 into 2. From 12.7 to 25, it will be 4 into 2. And if the thickness of your parent metal, your nominal thickness is more than 25 mm, it will be 5 into. So, according to your nominal thickness, we'll add up the allowable reinforcement plus protrusion, and summation of all this will be known as a effective thickness. So, whatever the effective thickness will be there, we will be select that penetrometer which laying the 2% of that effective thickness. So here one example is there. Suppose we are going to select the penetrometer for a 10 mm thickness. Then for the 10 mm allowable reinforcement and protrusion is 3 plus 3. So it will come total 16 mm. So 2% of the 16 mm, that will come 0.32. So if we will select that penetrometer which has the wire diameter of 0.3, if we are considering the ASTM set, so if we are going for the ASTM set, then the sixth wire diameter of the total ASTM wire has the diameter of 0.25, which is less than 0.32. So we will select ASTM 1B penetrometer, and if we select the ASTM 1B penetrometer, it is starting from the wire number 6 to wire number 11. Okay. So if we are using the 1B penetrometer, the first wire, that is the sixth wire, need to be imaged into the radiograph when we will be interpreted. If the same diameter where we are searching for the DIN type penetrometer, it will come into the 11th wire into the DIN 6 ISO 12. So if we are selecting the DIN type penetrometer, we will select the set of DIN 6 ISO 12, and 11th wire of that particular set we need to be visible into the radiograph prominently when we will taking the interpretations of the radiograph. If that individual were sixth wire of ASTM or 11th wire of the DIN for the 10 thickness of radiography is clearly observed in your radiographic film, we can say your radiograph has achieved that 2% sensitivity, and that is the minimum requirement. If the same requirement, that is 0.32, if we are want to convert it into the thou values, we can multiply it by the 40, and the whatever the near about integral values, that is 0.32 into 40, it will come 12. So in that scenario, we can use the 12 thou penetrometer for the whole type. When we are using selected the wire type penetrometer or hole type penetrometer, the placements of these two is most important. During the radiography, the hole type penetrometer in generally we are placed into parallel to the weld within the 25 from the weld have depicted zone. And if we are using the wire type penetrometer, it will be perpendicular on the well such that it will be perpendicularly strike with the radiation beam. Our next thing that we will be discuss regarding the radiography technique. So basically in radiography, according to the positions of the source and according to the positions of the image that will be formed into the radiographic film, Uh, according to that, the nomenclatures of the radiographic technique has been decided. The thing is, radiographic technique is four type. One is single wall, single image. Second, single wall, single image panoramic. Next, double wall, single image. And fourth one is double wall, double image. So in case of single wall, single image, radiation is passing throughout the single wall and the image that is formed into the single wall only. In case of bigger diameter pipes or any kind of hollow section where we can able to produce the source at the center of the pipe and the entire circumference can be covered up with the film. So by the single exposure, we can take the radiography of the entire circumference joint. This technique is known as single wall, single image panoramic exposure. In this scenario, radiation is also passing through the single wall and the image that will be formed into the radiograph that will be also the single wall. If the piping diameter is very less or the piping section are enclosed from everywhere, there is no possibility to put the source inside the pipe. So in that scenario, we can go for the double wall single image technique. Here the radiation will be passing through the double wall and the image that will be formed, that will be only the individual wall that will be touched with the film. Uh, Whatever the radiation will be passing the double wall, but the image is formed only for the single wall because double wall single image technique is only allowed if the SFD, source to film distance, is more than 89 That means if the OD of the pipe is more than 89 we can proceed for the double wall single image. So double wall single image in generally we have carried out from the 3 inch and above diameter pipe. This is also known as a touching shot. And last one that is known as the double wall double image. That is the radiation passing through the double wall and the image that will be formed that will be also the double wall. But this double image we can use as a single image for the interpretation that is known as the superimposed technique, or we can separate both the image of the both the wall of the penetrating wall, and if we are able to separate these two image, then it will be known as a elliptical exposures. So ultimately elliptical exposure. So double wall double image, there are two type of double wall double image. One is a superimposed technique and second is known as the elliptical exposure. In case of superimposed technique, we are putting the source perpendicular on the weld, and in case of panoramic exposure, we are using the source at a definite angle. Okay. Now, in this training session, we are in this up to this much radiographic film interpretation and the identifications of the different type of defect that we will be discuss in our next session. Thank you everyone for participation. Thanks.